Good afternoon, everyone. My name is Lim Kong, and today I'm working with Asham for this project. And our project was about e-bike upgrade kit. So for the project descriptions, our project is like focusing on the battery as the battery case that have size like 360 times 90 millimeter that will be generate the powers to the electric motor. The battery also can switch it off and on and give the rider to be able to take the battery to charge it in the house or school or the place where they want to charge it. And also the battery can carry into the backpack, also can lock it into the bike, and also provide the rider easy to packable and extend the range of the riding. So for the scope to lead these projects to be done, we need to process with the Australia regulation that they only allow us to use like 250 watts power supply and with the speed like 25 kilometer per hour. So and we also try to like testing our designs to see like is there any improvements that we can change to improve our designing. So to sum up this, our goal to design as a efficiency battery life that apply with the Australia standard that we are planning to design to the ways that give the rider more range riding for the like more than like other company e-bike. So and our purpose is that giving the extra of the battery life to the e-bike like we are just like our purpose is like extra the battery life. So like we're using the power bank for like charging our phones. So we use the extend the battery life that we can swap the wall. We take it off and take it on. We just swap it out. And so they will give it easily to change the battery and the battery. So an example for this is will be easier for the customer to charge the battery inside the house or inside the school. Not like another company, they using the battery just stick the battery with to the bicycle. That is hard for us to charge the bicycle. If you want to charge the bicycle, you have to bring the whole bicycle into with it. So it's not like more efficiency or more productive. So for our project requirements, so is that we can use our hands to swap or replace the battery that not like giving the customer or the clients like to carry more tools to repair or change the battery. Also, we need to be safety and security system. Like we create a locks into the bicycle battery. So when the customer parks somewhere and we can lock it, prevent from the thief stealing. And more than that, we also need the battery that is suitable for any conditions like raining or hot weather. So they must be like secure about that because we don't want our customers to be experienced with the explosion or electric shock. And here is for our need and analysis. As you can see, safety is really important because we have to need to be followed to the weak road rule like 250 watts. And for the weight, we have to targeting to the market like lightweight because it's easy for the customers to carry on to bring somewhere. And the most important is no tool because we can use hand as a tool to swap the battery to place it and take it up and charge it. And for the cars, we don't really like matter because we use the battery cell and more than that we use the recycled material like a plastic recycle that we get from the oceans or something. We just make the case of the battery. And for the durable is suitable for any seasons. and the difficulty, as we can show at the right hand side. And here is the specifications of table. Like safety, we got talk about safety again. As we would know, like e-bike is really like they focusing on the power supply, because if we using the power supply more than like 250 power, we won't be able to sell it in Australia, so it might be hard for us. So, and for the weight requirements, we would be minimize the weight as low as possible, so we can reduce it to like 3.2 kilometer, I mean like 2 kilograms. And for the price, we in Australia dollar, and yeah, and for touchable, we just take it off and take it in. We make sure testing it, is it touch on or touch off to take it off or not. And for the next slide, I will give it to Hasham.
Thank you. House of Quality, as known as QFD. Didn't got that part. Thank you. The House of Quality is defined as a product planning matrix that is built to show how customer requirements related directly to the ways and methods companies can use to achieve those requirements. And also QFD is what you mainly focus on and compare with the other companies. Lincoln. Next slide, please. Yeah, this is work WBS, known as work breakdown structure. Uh, this is to talking about the steps used to complete this project. We divided this to four main parts: safety, driving concept, intended use, and project management. Our project is mainly focused about battery extend or battery replacement. So the pros and cons of an e-bike upgrade kit is shown here. Some advantages are cost effective. By upgrading the e-bike, the battery capacity can be increased. The power of the battery can be distributed as front wheel drive, um, center wheel drive, back wheel drive, and hub drive. Next is Gantt chart. So this slide shows the methods of doing the production smoothly with minimum warehouse storage, and this used to talk about the duration of each task. So the raw materials are sorted according to the necessary period of time production. So I would like to hand over this to Lincoln again. Thank you.
Yep, now we're talking about the design concepts. So our design concept, we have three design concepts. So for our first design concept is the front wheel drive systems. So the front wheel drive system is where the motors is in the front wheels, as we could see in the pictures, and we would like to place the battery underneath of the springs that we put the wire and brings bring the powers or the energies to the front wheels so it can move it forward. And for second concept is a mid-wheel drive. As a mid-wheel drive, we're using like the motors like underneath of the crack, like on like next to the pedal. So we're riding with the pedal and the chain or everything is in there, so it should be okay and easy for the battery. And this our uh, third concept is about the back wheel drive systems. So for the back wheel drive system is like layout from like the motor is at the back. As you can see in the pictures, you have the battery placing on like underneath of the seat that have the wire that stick next on the like body frames and then giving the powers. or the energies to the at the back wheel so that they can like to move forward or brake or something. So for our final design, we would like to choose the mid-wheel drive. So after it costs like we're choosing the mid-wheel drive, as we could see, it's easy to attach the battery and give the power to the motor. As the front wheel drive, it's very hard for us to connect the wires because due of the rotation of the wheels, it's like turn left or right, so it's hard for us. They might bend the wires. And also for the back wheels, it's nearly to the gearbox, so it's we're just protecting like from the gearbox shifting wrong or something. It might be landing that have collision with our wires that disconnect our power. So we would like to choose the mid drive because the mid drive also have the wires stuck just put into the body frames and connect it to the motor. And here's some of the battery that we're designing that we can take off and take it in, as you can see in the picture on top. And here is our like a symbol animation that 360 look around for the battery. And for this one is how's the battery symbols into the bike. As you can see at the left hand side is the bicycle that we focusing on, like on the like Yati BS5 mountain bike. It's nothing touching it, but for our idea for the battery, we would like to put it on top of the body frames, as we could see like the top view, so that will be like generates the powers to the motor. And the reason I don't want to put the battery behind of the front wheels because I scared like because of the spring will be like moving forward because of the compressions, so that will make the battery and the front wheels touch each other, so they will be disattach the battery, so it will not good to our battery. And yep, thank you for listening.
Okay, I would like to thank Lim Kong for the presentation and also from Ashan for coming here. Thanks everyone. Audience, please give a round of applause for the presenters. Okay. Okay, very good. I understand that the scope of your design was with a removable battery, and that's a very good idea because nowadays the upgrade kit you can purchase them from here and there. So those are mostly standard few variable, but when it comes with mounting the battery to the structure of the bike, that is a real issue. So you address that issue by designing the battery. That was good. Question from the audience? Questions? Come on, don't be shy. Ask question. Just this is a way of showing that you are engaged. All right. So if there is no question, I'm going to bring the next thing.